On page 241 of the textbook, you will find problem number 40, where the instructions are: find the open intervals on which the function is increasing and decreasing, and then identify the function's local and absolute extreme values, if any, saying where they occur. So in part A, I'm supposed to find the intervals on which this function is monotonic, where it is either going up from left to right or down from left to right. And then on part B, I'm looking for local mins and maxes. So I need to take a derivative. I think what I'll do first is a little bit of algebra. I'm going to distribute the x to the 2/3 through this function. I think that'll make it a little easier to take my derivative. X to the 2/3 times x to the 6/3 is x to the 8/3 minus 4x to the 2/3. Now I can take my derivative. If you wanted to from the start, you could have just used the product rule. I'm going to take the derivative of what I think is a slightly simpler function. So the power rule says this will be 8/3 x to the take 3/3 away, and I have 5/3, minus 8/3x to the minus 1/3. And there's my first derivative. I have several choices for how to proceed here, but what I'm looking for next are any critical values. Any place where this first derivative is either equal to 0 or is undefined. Well, right away, I know that a critical point will be 0. Because I can't plug 0 into the bottom of a fraction. That will make this first derivative undefined. So I have one critical point. Now I need to imagine setting this first derivative equal to 0. There are multiple things you could do here. You could find a common denominator, or you could just set it equal to 0 and then see what happens. I think that's what I'll do here. So 0 equals 8/3 x to the 5/3 minus 8/3 1/x to the 1/3. We could divide everything by 8/3 and get that out of there. And I'm going to imagine going on and adding this term to the other side, which would give me the statement 1/x to the 1/3 equals x to the 5/3. If I multiply x to the 1/3 to both sides, I'll get 1 equals x to the 6/3 or x squared. Taking a square root of both sides, x is equal to plus or minus 1. So now I have 3 critical points to consider. I have 3 places where I need to think about whether my first derivative is positive or negative. So let's see. The derivative formula I have, k prime of x was 8/3 x to the 5/3 minus 8/3 1/x to the 1/3. I like setting up this number line for the first derivative. It's how I really think about the first derivative test for local extreme values, where I write in the critical points, and on each interval I'm thinking about whether my first derivative is positive or negative. And so I can pick a sample point in each interval. I usually don't even write this down, but we're just getting used to this. So I'm going to go on and pick a value. I try to pick the easiest thing I can think of on all the intervals. And so -2, -1/2, 1/2, and 2 are what I'm going to use. And I just need to plug them in for x and see whether I get a positive or a negative. I think with this function, I'll type my first derivative into my TI-83 and use it to help us out. So 8/3 x raised to the 5/3 power minus 8/3 times 1/x to the 1/3 power. And I could have used a negative exponent there instead of the 1/, but I'm going to leave it like this. And now I'm going to go into my table of values where I had some things in there from the last time I did something like this, but I need to plug in a -2, and I got out a negative value. I need to plug in a -1/2, where I get out a positive value. I'm going to plug in a +1/2, where I get out a negative value, and then finally I want to plug in +2, and I'm pretty sure I see what's going to happen. That's going to be a positive. So I can tell you that this function is increasing on the intervals from -1 to 0 and also on the interval from 1 to infinity. And again, not a union symbol between here, a comma, because I'm saying I'm going up from left to right from here to here, and I'm going up from left to right from here to here, but I don't know how the two things compare to each other. And I'm decreasing on the interval from minus infinity to minus 1, and also from 0 to 1. All right, now let's think about the absolute mins and maxes. So I decrease until minus 1, and then I increase. So there's going to be a local minimum at minus 1. I increase and then decrease, so at 0 there will be a maximum. I change from a negative to a positive at 1, so that will be the location of another minimum. So, a local minimum of some number I need to find occurs at minus 1. Another local minimum of some number I need to find occurs at positive 1. And a local max of some number I need to find occurs at 0. So I need to go through and fill in these blanks, and that's where I have to remember that's what the function does. My local min is a y value that happens at an x value. So I need to think about my original function k of x, which was x to the 2/3 x squared minus 4. So I just need to plug in these x values to find the corresponding y values about where what the min and max actually were. So I'll start with this last one. Plugging in a 0 here, I actually get out a 0. So the local maximum of 0 occurs at, well, 0. The local min, a local min occurs at minus 1. So when I plug a minus 1 in there, let's see, minus 1 to the 2/3 will be 1. And then I square that 1, and I get a minus 3 there. So a local minimum of minus 3 occurs at minus 1. And then I can come back here and do the same arithmetic. 1 to the 2/3 is also 1, and then x squared minus 4, when I plug that 1 in there, I also get out a minus 3. So I have a local min at minus 3 in two different places, and a local max of 0, and that occurs at 0.